In this video, we're going to discuss about nuclear fission. Nuclear fission and fusion reactions are the two fundamental types of nuclear reactions. Nuclear reactions are phenomena in which one or multiple atomic particles are created from the collisions between two nuclei or a subatomic particle and one nucleus. The nuclei created from nuclear reactions are not similar to the reacting nuclei or parent nuclei. So what exactly is nuclear fission? Nuclear fission is a reaction through which two or more light nuclei collide to form a heavier nucleus. The nuclear fission process occurs in elements that have a low atomic number, such as hydrogen. Nuclear fission is the opposite of nuclear fission reaction, in which heavy elements diffuse and form lighter elements. Both nuclear fusion and fission produce a massive amount of energy. Nuclear fission is when two or more atomic nuclei fuse to form a single heavier nucleus. In the reaction, the matter is not conserved because some of the mass of the fusing nuclei is converted to energy. So here are the differences between nuclear fission and nuclear fusion. Nuclear fission is a nuclear reaction that splits a heavy atom into multiple smaller ones. It does not occur naturally. It produces a large quantity of energy, and it does not require a lot of energy to split an atom into two. While the nuclear fission is a nuclear reaction that combines two or small atoms to form a large atom. The universe is full of instances of nuclear fission reactions. Every star uses it to produce energy. It produces greater energy than the fission reaction. It requires a lot of heat and pressure for the process to happen. Applications of nuclear fission. We are still at an experimental stage as far as nuclear fission reactions are concerned. Clean. No combustion occurs in nuclear power, fission or fusion, so there is no air pollution. Less nuclear waste. The fusion reactors will not produce high-level nuclear waste like their fission counterparts, so disposal will be less of a problem. In addition, the waste will not be of weapons-grade nuclear materials as is the case in fission reactors. If appropriately utilized, nuclear fusion energy is the answer to the world's power crisis problem. It is clean and produces a minimal amount of nuclear waste as compared to fission reactions. In addition, the fuel for fusions, deuterium and tritium, are also readily available in nature. Thus, scientists are hopeful that fusion will be a viable alternative power source in the coming centuries. So how does nuclear fission take place? Let us look at the nuclear fission example below to understand how the fusion reaction occurs. When deuterium and tritium fuse together, their components are combined to form a helium atom and a fast neutron. As the two heavy isotopes are combined into a helium atom and a neutron, the leftover extra mass is transformed into kinetic energy. The participating nuclei should be brought together for the nuclear fusion reaction to occur. They should be brought so close to each other that the nuclear forces become active and glue the nuclei together. Nuclear fission in the universe. Every star in the universe, including the Sun, is alive due to nuclear fission. It is through this process that it produces an enormous amount of heat and energy. The pressure at the core of any star is tremendously high, and that is where the nuclear fission reaction occurs. For example, the temperature at the Sun's core is around 15 million degrees Celsius. At this temperature, coupled with very high pressure, two isotopes of hydrogen, deuterium and tritium, fuse to form helium and release a massive amount of energy in the form of heat. Around 600 million tons of hydrogen are converted into helium every second in the Sun. The reactions which take place in the Sun provide an example of nuclear fission.